In example 12.1, we are told that f represents a map with the domain of all real numbers mapping to other real numbers, and we are expected to express f of x in vertex form and state the element of f that represents the vertex. So we're being asked to do two things here with the equation for f, known as f of x. Number one is we're supposed to write f of x in its vertex form, meaning a times x minus h squared plus k. And number two, we're supposed to state the element of f that represents the vertex. F is a function, which at its core is a mapping. The elements of a mapping are ordered pair. The ordered pair that represents the vertex is located at h comma k. So by virtue of doing the first part, getting the vertex form, we should automatically get the second part for free. So taking a look at the first equation, here for part A, we have f of x equals x squared minus 2x plus 3. And that is currently in standard form. And the reason why I know it is in standard form is because I have the ability to be able to say that a is 1, b is negative 2, and c would be equal to 3. So my goal here is to be able to rewrite the equation so that way I can identify the a, h, and k. This is going to require a little bit of creativity. Now, one form of creativity that we've used throughout the course is called the creative one. We saw an example of creative one when we work on getting a common denominator, say, for a fraction. So let's say that I have the fraction 1/2. I can multiply top and bottom by 2, and that means that 1/2 would then look like 2/4. And I don't think any of us would argue that 1/2 is equivalent to 2/4, but they look different. They're different forms, but they are expressing the exact same value. So that's what's going on here with this standard form turning into vertex form. I'm going to have to use something creative to be able to help it transform into something different. So rather than using a creative 1, we're going to use what's called a creative 0. Let me show you how this works. So I'm going to go ahead and copy down the first two terms of f of x, x squared minus 2x. And I'm going to add 1 and then subtract 1. Then I'm going to copy down the plus 3. So this add 1 minus 1 business would really just cancel itself out. In other words, all I did was just add 0. So adding 0 does not change the equivalency of my statement. It's just a creative way of rewriting it. Just like multiplying by 1 doesn't change the value of something, it just gives us an opportunity to be able to creatively rewrite something, specifically in this case a ratio here with 1/2. So this creative 0 that we've used ends up giving us a chance to be able to do some factoring. So I'm going to group together the first three terms, x squared minus 2x plus 1. And these first three terms are known as a perfect square trinomial. And perfect square trinomials are of particular importance with this type of rewriting because it allows me to be able to factor into two of the exact same factor. Watch. So x squared minus 2x plus 1 is going to become x minus 1 times x minus 1. And then the minus 1 plus 3 will combine to become plus 2. So every time you have a perfect square trinomial, you will end up getting the exact same factor twice, which means that we can write it in its condensed form using exponent x minus 1 squared plus 3. And just like that, we now have the vertex form. And I know that it's the vertex form because I can say that a would be equal to 1, just like a is equal to 1 in the standard form, but my h is also equal to 1 and k would be equal to 3. So that means that my vertex must be located at the ordered pair 1, 3. So thinking about it from a transformation perspective, right here where it says x minus 1, that means that I'm going to shift to the right by 1, and then this plus 3 means I'm going to end up shifting up by 3. Hence the vertex will be located at 1, 3. Now this whole process of the creative zero, the perfect square trinomial, and then rewriting it with the exponent, this has a name. This process is called completing the square. And this is a skill that you were supposed to be taught prior to coming into this course, but I know not everyone has done it in a while or even remembers doing it. So the preliminary chapter in any college algebra textbook should have information about completing the square, and certainly searches on the internet will help you to find some videos about completing the square as well. There are going to be other examples of this here in example 12.1, part B, C, and D. But if you find that you're really struggling with the concept of completing the square, you might want to go find some additional resources or come talk to your instructor about that.